So if you're watching this video, you should have already completed the practice quiz for 3.1 through 3.4. I'm going to go through here and explain all of the problems to make sure you are good to go for tomorrow's quiz. So the first set here should be familiar. This is similar to what we had on our last quiz. We were just asked to find the domain. And again, there's two things we have to be worried about that could be domain restrictions. And that's when we have an even-powered root or if we have the x in the bottom of our denominator. So in the first one here, we have a square root, and we can't take the square root of a negative. So we need to know when is 6x minus 2 greater than or equal to 0. So we can just solve now this inequality. 6x is greater than or equal to 2, and x is greater than or equal to 1/3. So now we can put that in interval notation. We're going to use a bracket because we have greater than or equal to, and then 1/3 to infinity. As we move over here, we have x in our denominator, and we cannot have 0 in the denominator because it's going to give us an undefined fraction. So the first thing we have to do is we're going to factor this. So it's going to factor to be x minus 4 and x plus 3. Again, negative 4 times 3 gives us negative 12. We add them, we get negative 1. We can solve each one of these now. We can see that x cannot equal 4 and x cannot equal negative 3. Those are the two values that could give us 0. So now our intervals, so it'll be negative infinity up to negative 3, union negative 3 to 4, union, and lastly 4 to infinity. So those are domain questions. Again, square roots and 0 on the bottom is what we have to be careful of. Moving on. Even, odd, or neither. Remember, in all of these cases, we are going to plug in f of negative x. When we plug in f of negative x, if the function does not change, it's even. If it is opposite, it is odd. And if it's neither, it's neither. All right, so we're going to go for number 3. We're going to plug in f of negative x. So that'll be 4 negative x to the 3rd minus 9 negative x to the 5th plus 20 times negative x. So we have an odd number of, we have an odd exponent. So we're going to get negative 4x cubed. Again, odd exponent, so this stays negative. Negative times the negative is a positive. 9x to the 5th and minus 20x. So if we look, opposite sign, opposite sign, opposite sign. So since all of our signs are opposite, this function is odd. Moving on to number 4, exact same thing. Again, figure out what is f of negative x. So we plug that in. So it's 10 negative x to the 6th minus 4 negative x to the 4th plus 8 times negative x squared minus 9 times negative x. So plug in negative x for all of those. So even power becomes positive, so it's 10x to the 6th. Again, even power, so it would be minus 4x to the 4th. Even power plus 8x squared minus plus 9x. So same sign, same sign, same sign, opposite signs. So it's a mix. So the answer is this function is neither even nor odd. And lastly, again, figure out what is f of negative x. So it'll be negative 3 negative x to the 8th plus 5 times negative x squared plus 10. So now we can go through and simplify. So negative number to an even number, it's going to be positive, so it's negative 3x to the 8th. Again, negative to an even power, be positive, so plus 5x squared, and this stays plus 10. So same sign, same sign, same sign. This function then is even. Moving on, we want to figure out when this function is increasing and decreasing. So whenever we're doing that, we have to look for the x values. So it changes direction here, and it changes direction here. Now this is going to take a little bit of guesswork because it looks like it could be, it's not exactly on a nice point. So I'm just going to call this negative 2.75, and I'm going to call this x equals 0.75. If you have something a little bit different, that's perfectly fine as long as you're kind of in the ballpark of those two values. So now we're going to write when it's increasing and decreasing in interval notation. So we'll do increasing first. Remember, whenever we are looking for increasing and decreasing, we are moving from left to right. So in this part here, it starts out increasing. So it's going to be from negative infinity up until that negative 2.75, and we'll put a bracket. And then we'll union, and then now it's going to be decreasing. And then we'll finish up increasing over here. So that'll be bracket from 0.75 to infinity. So those are the two places where it's increasing, which is here and which is here. And now we're going to look at decreasing, which is in the middle part between those two. So negative 2.75, comma, 0.75 bracket. And again, when you combine all of these increasing and decreasing sections, you should get your entire domain, which is from negative infinity to infinity, so we are good to go. Again, remember when you are doing increasing and decreasing, you always want to use the x-coordinates of those points. Moving on to average rate of change, that is just like slope. So in this case, to find average rate of change, we are going to do f of 9 minus f of 4 over 9 minus 4. It's your change in your outputs over your change in your inputs. So f of 9, we plug in 9 to this, so 3 times 9 is 27, minus 2 gives us 25. Plug in 4, 3 times 4 is 12, minus 2 is 10, over 9 minus 5, I'm sorry, this should be a 4. 9 minus 4, which gives us 5. So we'll have 15 over 5, which is 3. And as we kind of should have guessed that from the linear function, the slope and the average rate of change are constant, so they're not going to change. Now we don't have a linear function, but we're still going to do the exact same thing. So it'll be f of negative 5 minus f of negative 7 over negative 5 minus negative 7, so that's going to turn to a positive 7. So when I plug in negative 5, I get negative 215. And when I plug in negative 7, I get plus 637 over, and now this gives me 2. So this is going to be 422 when we combine those over 2, which gives us an average rate of change of 211. Same exact thing here. So we'll do f of 3 minus f of 0 all over 3 minus 0. So when I plug in 3, I get 36. When I plug in 0, I get 0. 3 minus 0. So it ends up being 36 over 3, which is 12. The same thing, f of 3 minus f of 0 over 3 minus 0. So 3 cubed is 27. Minus 15 gives us 12. So 12 minus 0 over 3, which is 12 over 3, which is 4. And last rate of change, or average rate of change, f of 100 minus f of 16 all over 100 minus 16. So it'll be 10 minus 4 over 84, which is 6 over 84, which will simplify to 1 out of 14. So again, average rate of change is just like slope. Figure out f of those 2 points, change in output over change in input. Next, we want to know how do these changes affect the graph. So negative f of x, so this is kind of like our c. So since the c is negative, this is going to flip, or you could say reflect, across the x-axis. If we had this f of negative x, which is different. This is going to flip across the y-axis. So when it's outside or before the function, it's going to flip across the x. When it's inside, it's going to flip across the y-axis. Okay? Now here, all right, remember, we want to figure out when does this equal 0. That's going to tell us how it moves. So x plus 2 equals 0. So since we get x equals negative 2 for that piece, that means that it is going to move left 2 units. And this 8 in front, it's going to stretch by a factor of 8. So, which is in other words, y values all multiply by 8. So it'll make it look a little bit thinner and taller. 14 along the same lines. So x to the 4th is reflected over the x-axis, shifted 3 units to the right, and then shifted down 4 units. So we have 3 things going on. We have a reflection, which means that we are going to have a negative sign. We have our x, and it's to the 4th power. So the negative sign takes care of flipping across the x-axis, shifting 3 units to the right. So that's going to go inside, so that's going to be minus 3. Remember, anything that's inside the parentheses is going to be opposite. And then up 4 units, we can take care of that by adding 4. So here is our new f of x. The negative tells us it's reflected over the x-axis. The minus 3 tells us it's shifted 3 units to the right. The plus 4 tells us that it's shifted up 4 units. Okay, 15 asks us, how does c affect the graph? Well, there's 3 things that can happen. C can be greater than 1. C can be between 0 and 1. And 3, C could equal a negative number. Well, if it's greater than 1, it stretches by C, which all of our y values are going to be multiplied by that. If it's a fraction in between 0 and 1, we say it compresses the graph, which makes it get a little bit fatter by C. And if it's C is negative, this is when we say it's going to reflect across the x-axis. So C is either stretches, compresses, or reflects, depending on what happens with what the value is. Okay, next question. It says graph this from the given parent function. So we have x squared here, which is our parabola. So now we got to figure out what's happening. Well, this plus 4 inside tells us that it's going to move left 4 units, and this here tells us that it's going to move up 2 units. So all you have to do is pick a couple points. So we'll pick our friendly 0, 0, 1, 1, and 2, 4. Those are kind of our common points. So now we just move each one of these points. So this is left 4, 1, 2, 3, 4, and up 2, 1, 2. So now we're here. Again, this moves left 4, 1, 2, 3, 4, up 2 units. Here, left 4, 1, 2, 3, 4, up 2. Left 4, 1, 2, 3, 4, up 2. And lastly, our vertex, left 4, 1, 2, 3, 4, and up 2. So now we can get, and again, this is an ugly graph, and I apologize. Hopefully yours looks a lot better. This should be curved, and it's a parabola. Lastly, the big one, a piecewise function, and we're going to list all of these things: domain, range, increasing, decreasing, constant. So for this problem, the easiest thing to probably do, I don't know if it's the easiest, but what I would recommend doing is I would graph this. So again, plug in your endpoints. So -3, we're going to plug in. So -3 times -3 is 9. 9 minus 2 is 7. So we're going to go over 3, 1, 2, 3, and up 7. 1, 2, 3, 4, 5, 6, and 7, and put a dot. And then we can plug in our other endpoint, which is -1. So negative 1 times negative 3 is 3. 3 minus 2 is 1. So negative 1, negative 1. Now, it is just this line segment here. And the reason being is this is our endpoint. This function only starts at negative 3. So we're not going to draw our arrow. This is the endpoint. It's or equal to, so we have a clear open dot. And this one here should be open. So open dot here, I'm sorry. And like I was saying, endpoint, negative 3, close dot. All right, so now we can plug in negative 1 for our next point. Well, negative 1 squared. Now we can close in this dot. Plug in 2, which gives us 4. So 2, 1, 2, 3, 4, which is here. And of course, we have 0, 0. So now we get that parabola going down and up. Okay? And lastly, x equals 4 from 2 on, which is this piece right here. Okay? So now we got to list all the pieces. So domain. Our domain starts at negative 3. And we're going to use a bracket because we have the or equal to. And it's defined all of the way to infinity. So nothing happens before negative 3. The range is just between two values. There's going to be no infinity here. The lowest value we have in our range, which is our outputs, our y values, is 0. And the highest that it's ever going to get is up here, which is at 7. So now we got to figure out, okay, when is this function decreasing? When is it increasing? And when is it constant? And again, for these, we're going to use our x values. So it's decreasing. It starts off decreasing at negative 3 and continues. It's decreasing here. And it's still decreasing for the first part of this function all the way down to the vertex. So it's going to be negative 3 to 0. And now it's going to increase from the vertex up to this point, which is from 0 to 2. And lastly, it's constant the rest of the way from 2 to infinity. Again, you can check these three parts should add up to our domain, which they do. Negative 3 to 0, 0 to 2, 2 to infinity. They're all connected. It gives us our domain. So that concludes this part of going over the review. Please feel free to watch any part of this again if you need to make sure you are good to go. Your quiz tomorrow is just like this. Same number of problems, same type of problems. Just changed the numbers, but it's going to be the exact same process. All right, hope you had a great day and good luck on your quiz.